Welcome to The Explainer. Today, we're taking this really awesome journey. We're literally going from just a simple folder of code sitting on your personal computer all the way to a fully functioning application that anyone, anywhere in the world can access. We're going to completely demystify the process of deploying a Node.js application to Amazon Web Services, specifically focusing on spinning up an EC2 instance. We'll be drawing heavily on a really great hands-on session by developers Kunal Verma and Abhishek Viramala to break all of this down step by step. Okay, let's dive into this. Here is our roadmap for today. First, testing locally. Second, setting up secure access. Third, actually launching our EC2 instance. Fourth, prepping that remote server. And finally, number 5, exposing the whole thing to the internet. All right, starting with section 1, testing the app locally and just getting our bearings. So before we introduce all the complexities of the cloud, we absolutely need to prove that our Node.js application actually works right here on our own machine. Now you might be wondering, hey, if it works perfectly on my laptop, why don't I just host it right there? Well, your local machine is fantastic for testing, right? But it's super restricted. Moving to a cloud provider like AWS and utilizing an EC2 instance completely removes a massive amount of maintenance overhead. You don't have to stress about hardware upgrades or your local Wi-Fi dropping or power outages. Plus, it scales beautifully. I mean, think about it. If your app suddenly goes viral overnight, AWS can seamlessly handle that traffic. Whereas your laptop, yeah, it would likely just freeze up and crash. To get things rolling, you're going to be spending a little bit of time in the terminal. Here's a really quick visual cheat sheet of the essential commands you're going to need. Git clone is what pulls the code from a platform like GitHub right down to your machine. CD lets you change directories and navigate right into that newly created folder. And ls/a is absolutely crucial because it lists everything in the folder, including the hidden files. If you're completely new to this, encountering these basic Linux and Git commands is totally normal, and trust me, they will quickly become second nature. Speaking of hidden files, one of the absolutely most critical elements of modern web development is the .env, or environment file. You see, the application we're looking at today integrates with Stripe to process payments, and Stripe naturally requires secret API keys to actually work. If you hard-code those sensitive variables directly into your application files, literally anyone who looks at your code can steal them. So the .env file acts like a secret vault. It allows you to securely store these credentials locally, keeping them entirely separate from your public code repository. So to test this locally, we just follow these 4 simple steps. We clone the repository, we create our hidden .env file and paste in our secret keys, and then we run npm install. Since this is a Node.js app, Node Package Manager, or NPM, acts a lot like Python's pip, if you're familiar with that. It essentially just goes out and fetches all the external dependencies your code needs to function. Finally, npm run start launches the application, spinning it up right in your browser at localhost port 3000. Let's move to section 2 and see how this builds into creating secure AWS access. Safety first. Assuming our local test went off without a hitch, we're finally ready for the cloud. But we're starting with security. When you first sign up for AWS, you're handed what's called a root account. This account has literal godlike powers over your billing and all your infrastructure. Industry best practice dictates that you almost never, ever use this root account for your daily tasks. Instead, we use something called IAM, Identity and Access Management. This is the service that lets you create specific users with very granular, restricted permissions. Setting this up is straightforward but entirely vital. From your AWS console, you just navigate over to the IAM dashboard, add a new user, and assign them a custom password. Then, you attach policies to that user. For example, you might grant this specific user the ability to only interact with EC2 instances. That way you ensure they can't accidentally go in and delete your secure database storage somewhere else. Once that's all created, you log out of your all-powerful root account and sign back in as this brand new secure IAM user. Section 3, launching an EC2 instance. This is your new cloud computer. All right, safely logged in, we reach the really exciting part, actually provisioning our cloud infrastructure. The core service we're utilizing today is EC2, which stands for Elastic Compute Cloud. The best way to think about an EC2 instance isn't as some huge abstract cloud concept. Actually, scratch that. Just think of it simply as a completely new blank slate laptop sitting quietly in an Amazon data center somewhere. You get to pick its operating system, how much memory it has, its processing power, and then you just rent it by the hour. When we go to launch our instance, we just have to make a few quick configuration choices. We're going to select Ubuntu Linux as our operating system. For the instance type, we'll choose the T2 Micro. This is incredibly highly recommended for beginners because it falls squarely under the AWS free tier, meaning you can play around and experiment without racking up some massive credit card bill. Finally, AWS is going to prompt you to download a .pem key pair file to your computer. Keep this file super safe. It is quite literally the digital key to your new server's front door. Moving to Section 4, Prepping the Remote Server. Time to fill in that blank slate. So our EC2 instance is now up and humming along in a data center over in Virginia. But remember, it's totally blank. We need to prep it. To install the software our app needs, we have to actually connect to the server. We do this using SSH, or Secure Shell. You can think of SSH as acting like a secure, encrypted tunnel running from the terminal right on your local laptop directly into the terminal of your remote cloud server. Now, what's really interesting about this slide is the command we actually have to run before we can even open up that tunnel. You must run chmod 400 on that .pem key file you downloaded earlier. In Linux permission structures, 400 essentially means the file is strictly read-only for the owner and totally inaccessible to literally anyone else or any other group. AWS requires this incredibly strict security. If your key file is openly readable by other users on your local machine, the SSH connection will just flat out be rejected. Okay, once we are successfully SSH'd into our Ubuntu server, we're basically just repeating our local steps, but doing it up in the cloud. We run sudo apt update to refresh the operating system's package list. We install Node.js and NPM. And by the way, it's super common to just rely on great guides like the DigitalOcean documentation to get the exact terminal commands for that. Then we run git clone to pull down our code. Now, because our .n file was deliberately hidden and kept out of Git, we actually have to recreate it directly on the server using a command line text editor, like Vim. Finally, we install our dependencies and run start. Section 5. Exposing to the internet. We've reached the final hurdle. Your terminal outputs that beautiful success message. Server is listening on port 3000. We've done it. The app is happily running in the cloud. But we're about to hit a final, incredibly common hurdle. You grab the public IP address of your brand new EC2 instance, you paste it into your web browser, you add :3000 for the port, hit enter, and absolutely nothing. It just times out. So the crucial point is, why is the site totally unreachable if the terminal is clearly telling us it's running? First off, don't panic. This isn't a failure, and you definitely haven't broken anything. As Kunal points out in the source material, the internet doesn't know that an application is running. We have to expose this port to the open world. This is actually a deliberate, highly vital security feature of cloud computing. And this brilliantly illustrates the concept of AWS security groups. Try to think of these as an invisible virtual firewall wrapping entirely around your EC2 instance. By default, AWS essentially blocks almost all incoming traffic just to protect you from malicious actors randomly scanning the internet. You have to go in and explicitly define inbound security rules to let the good traffic pass through. Take a look at the default setup. When we launched our instance, AWS actually helpfully opened port 22 for us. That's the dedicated port for SSH traffic. That is literally the only reason we were able to tunnel in and configure the server in the first place. However, our Node.js application is running over on port 3000. Because port 3000 wasn't explicitly allowed to pass through the firewall, our web browser requests simply hit a brick wall and timed out. To fix this, we just have to perform the magic steps to punch a little hole in that firewall. Back in the AWS console, under your EC2 instance's security tab, you just edit the inbound rules. You add a custom TCP rule, specify port 3000, and set the source to 0.0.0.0/0. In networking terms, that specific source IP block is universally recognized as meaning anywhere. You hit save, and that updates the firewall instantly. Now jump back to your browser and hit refresh. Success! Your Node.js application, which was previously trapped entirely on your local hard drive, is now globally accessible. Literally anyone with your EC2 instance's public IP address can view and interact with your work. As the host really emphasized, taking an application from a local environment all the way up to live, functioning cloud infrastructure is a massive milestone. You should absolutely give yourself a pat on the back for that one. By simply understanding these basic terminal commands, securing your access with IAM, launching an EC2 server, prepping it via an SSH tunnel, and managing those inbound security rules, you have essentially unlocked the foundational skills of cloud engineering. You are no longer just limited to what your laptop can handle. So the only question left really is, armed with this awesome new